So I'm Regina Espoli, your math teacher. So we are now done in discussing permutation and combination. So for this week, week 6, we are going to focus on the union and intersection. So I know some of you are familiar with this lesson since we've done this part or you've discussed this part when you are in grade 7. So the topic is all about set. So for this lesson's objective, illustrates events and union and intersection of events. So now, you know the objective of this lesson. Are you ready, grade 10, to learn something new? Let's go! So before we proceed on the lesson, so let us first try to understand or identify what are these symbols. Okay, I will give you 5 seconds to think first. Okay, the first one, what is this symbol? Aha! That is union. How about the second one? Very good! That is what you call intersection. How about the third one? Alright, this is what you call empty set or null set. So let's try to figure out what is this figure. How about this one? Very well said. This is what you call Venn diagram. And it's very common to see this kind of figure in every math lessons. So let's consider this 6-sided die experiment. So event A represents the number is add. So in the 6-sided die experiment, those are 1, 3, and 5. So event B represents that the number is a multiple of 3. So those are 3 and 6. And for event C, represents that the number is a multiple of 4. So this is just the number 4 itself. So as you can see, there is a number outside the circle, and which is number 2. 2 is not an odd number, and at the same time, it is not a multiple of 3. That's why it is not inside the circle. So then, we can call it a complement. After that, we enclose it in a rectangular figure to show that this is an example of a universal set. Let's talk about sample space. In a mathematical experiment, the set of all possible outcomes is what you call sample space. It can be denoted as capital letter S. Therefore, in our given 6-sided die experiment, we can say that the possible outcomes or what you call sample space are 1, 2, 3, 4, 5, and 6. So, if we are asked how many elements are there in the given set S, so we are referring to the cardinality of the set. So, cardinality of the set is denoted as n of S, referring to the set itself, the number of the number of the elements of a given set, equals 6. Why? Because there is only 6 elements or 6 possible outcomes in a given 6-sided die experiment. Another one is events. Events is a collection of your outcomes. It is also a subset of your sample space. So, given in our Venn diagram, there are 3 events happen. So, event A, event B, and event C. If we are trying to recall what are those events, so event A represents the number is add, event B represents that the number is a multiple of 3, and event C represents that the number is a multiple of 4. Another word is what you call the probability of an event. Probability of an event is a ratio that compares the number of possible or favorable outcomes to the number of possible outcomes. So if we are using a formula, we have P of E is equal to our numerator is the number of ways that an event may occur over the number of possible outcomes. Meaning in our numerator, we are talking about the specific outcome that may occur in a given experiment over the total number of possible outcomes that may occur in our given experiment. Experiments are activities that will give defined results, such as rolling a die, tossing a coin, randomly choosing a ball. So in terms of having tossing a coin, so that is what you call an experiment. And when we talk about outcome, it is the result of your experiment. Let's say example. Experiment is having or tossing a coin. When we toss a coin, there is only two possible outcome. It is either head or tail. Do you understand? Very good. Okay, so let's try to figure out the answer in this question. So, what are the elements common to events A and B? So, let's try to look in our Venn diagram. So, as you can see, there is an intersection between our event A and event B. So, that intersection from our illustration is what you call the common element. So, therefore, we can say that the common element for event A and event B is the number 3 based on our illustration from the Venn diagram. Okay, so let's try to talk about the union of two events. So the union of two events, A or B, can be written as A union B. So these are the elements found in event A, event B, or in both A and B. So let's try to differentiate. When we say union, it is all the elements that we can see in a given events, whether it is A or B or in both in A and B. So letter U tells us that this is the universal set. All the elements involved in a given set is present inside the universal set. And then we have event A and event B. So as you can see, all the portion of event A and B is shaded, meaning to say it is what we call union. It consists of all the elements of A and B. And take note that if they have common elements, we only write it once. In determining the union of event A and event B, the first thing to do is write the possible outcome on its respective event. So for event A, we have 1, 3, and 5. And for event B, we have 3 and 6. So as you can see, there is a common element which is 3. So in writing A union B, it will be 1, 3, 5, and 6. So as you can see, this is the correct way on how we write the union of A and B. On the other hand, A union B is equal to 1, 3, 3, 5, and 6. So this form is incorrect since the common element should be written once. So let's talk about the intersection of two events. The intersection of two events, events A and B, written as A intersection B. So these are the elements found to both events A and B. So let's take note that when in terms of intersection of two events, so we are just talking about the event or the possible elements that can be found to both event A and event B. So in the previous Venn diagram, in terms of union, all the shaded or all the region are shaded. So here, in intersection of two events, the only shaded part is the middlemost part of the event. So it is where the two events intersect or common to one another. In finding the intersection of event A and event B, again, we write all the possible outcomes for event A, 1, 3, and 5, and for event B, 3 and 6. So take a look on the events A and B elements, wherein we can see that there is a common element which is 3. So therefore, we can say that the intersection of A and B is 3 respectively. So let's talk about complement of events. The complement of event, denoted by A complement or A prime, are the elements that are not in event A but found in the universal set. So as you can see, universal set is a very important thing in intersection and union. Why? If we are looking for the complement of A, B, and C respectively, so we can see all the elements in the universal set. Considering this figure, we have there the set A. And then, when we get the A complement, we can see it just outside the circle. So all the portions or all the elements that we can see outside the circle is what you call the A complement or the A prime. In determining the complement of a given set, we have A complement or A prime, B complement or B prime, or C complement or C prime. So the first thing to do is write all the universal set denoted as letter U. So we have 1, 2, 3, 4, 5, and 6. So event A, it represents the number that is added. So you have 1, 3, and 5. So event B represents that the number is a multiple of 3, so we have 3 and 6. Event C represents that the number is a multiple of 4, so we have 4. So take a note that this is a 6-sided experiment. So in finding the A prime or the A complement, we have 2, 4, 6 respectively. So these numbers are not present in event A. For finding B prime or B complement, we have 1, 2, 4, and 5. So these numbers are also not present in event B. So C prime or C complement is equal to 1, 2, 3, 5, and 6. So these numbers are not present in event C. So these are the complement of a given set. Okay, so let's try to answer the different examples in your learning activity sheet. So for example number 1, so there are 10 cards numbered from 1 to 10 in a bag. A card is drawn at random from the bag. Let A be the event that the number is a multiple of 3, B be the event of the number is a prime number. So find the following. A. So you need to find the intersection between A and B. So for letter B, you need to find the union of your event A to event B. And for letter C, you need to find the union of your A complement or A prime to your B complement or B prime. So for example number 1, so our number 1 or first item is A intersection B, number 2 is A union B, and number 3 is A prime union B prime. So as you can see, the first thing to do is write the universal set. So for universal set, we denoted it as letter U equals 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So for our event A, we have 3, 6, 9. And for our event B, we have 2, 3, 5, 7. So for our answer in number 1, the intersection of A and B is 3, since the common element of this particular event is 3. For number 2, the union of event A and event B is, let's take a look or let's recall the definition of union. It is either both A and B. So we are going to write all the elements of event A and event B respectively. So that is 2, 3, 5, 7, and 9. So for our number 3, so we need to identify first the complement of A and the complement of B. So we write A prime and B prime. So for A prime, we have 1, 2, 4, 5, 7, 8, and 10. And for B prime, we have 1, 4, 6, 8, 9, and 10. So if we are going to find the union of A prime and B prime, so that will be equal to 1, 2, 4, 5, 6, 7, 8, 9, and 10. So for example number 2 in your learning activity sheet, given event Q is an even number wherein your x should be less than 15, and event T is a multiple of 5 wherein your x is less than 20, you need to find the following. The first one is the intersection between Q and T, and the second one is the union between event Q and event T. So for example number 2, the first item is the intersection of event Q and event T. And second item is the union of event Q and event T. So the first thing to do is write all the possible outcomes on the given event. So in event Q, we have an even number wherein their x is less than 15. So those are numbers or even numbers that are less than 15. Such 2, 4, 6, 8, 10, 12, and 14. So for event T, these are numbers that are multiple of 5, but it should be less than 20. So those are 5, 10, and 15. So now let's try to figure out the intersection of event Q and event T. So the intersection will be the common element of these two events. So that is 10. Okay, so the second one, the union of event Q and event T. So we are going to write all the elements of our event Q and event T respectively. So we have 2, 4, 5, 6, 8, 10, 12, 14, and 15. Okay, so let's try to answer example number 3 in our learning activity sheet. The extracurricular activities in which the senior class at Community Vocational High School participate are being shown in the Venn diagram. So using this Venn diagram, we are going to figure out the answer on the following questions. So how many students are in the senior class? So we're just going to write all the numbers that we can see in the Venn diagram, since it all represents the total number of the students in that particular senior class. So if we add all these numbers, it will come up into 345 students. Okay, so next is number 2. How many students participate in athletics? So as we all know, when in terms of athletics, all the numbers inside the circle of athletics will be involved. So we have 137 plus 4 plus 10 plus 8 will come up into 159 students. So for question number 3, if a student is randomly chosen, what is the probability that the student participates in athletics or drama? So we need to find the union of athletics and drama so that we can identify the favorable outcomes. And in terms of OR, we are talking about union. So using the formula, we can come up of P of E is equal to the favorable outcomes over the total number of possible outcomes. So since we all know that the total is 345, then substituting it in our formula, P of E is equal to 227 divided by 345 yields to an answer of 0.66. So question number 4. If a student is randomly chosen, what is the probability that the student participates only in drama and band? So the word that we need to identify is only. So in terms of only, we are using intersection. So for intersection, we're just going to write 30, since it is only 30 students are involved in drama and band. So divided by 345 yields to an answer of 0.09. And for number 5, how many students did not participate in any 3 circular activities?
So there are 67 students. So we can say that they are still included in the sample space since we are talking about total number of students.
So these are the different terminologies that you need to know in terms of having union and intersection of two events. Sample space, event, experiment, outcome, and probability of an event. I hope you can illustrate them one by one and you can now answer your learning activity sheet. So for our assignment, try to define or try to look for the meaning of probability so that you can have a prior knowledge in this topic that has something to do with our next lesson. Since we are in the middle of pandemic, always wear your face mask when you are outside in your house. Avoid or provide or observe social distancing. And thank you for watching.